Welcome to Lumia Lab Live, the internet's largest orthostatic research lab, where you can learn from the world's best doctors and help advance science right from your sofa. I'm Daniel, and oh, here the audio is kind of going funny here. Can you all hear us? Amanda, you coming through? All right, there we go.
Well, I'm Amanda. We're your hosts for today's Lumia Lab Live, and I'll be helping to analyze and write up what we find here today to post on the Lumia website. So today we have a very special guest. You've probably heard of him since he's written more papers on POTS than anyone in the world has. He runs a big POTS research program at the University of Calgary. He writes the guidelines for POTS and other orthostatic conditions. He was president of the American Autonomic Society and also the first ever Dysautonomia International Physician of the Year, and probably countless more accomplishments. So please introduce our guest, Dr. Satish Raj.
Woo! Hey.
Guys, thanks for having me. Daniel, it's good to be here at the first Lumia Lab session, and Amanda, always good to see you.
Good to see you.
Thanks for joining us, Dr. Raj. So we'll actually just be jumping right into it, move quickly here. So we actually prepared your slides. Our engineer, Greg, has actually drawn up some of the slides that you'll be covering today. So would you please cue the drawings? All right, please take it away.
So one of the, I guess one of the key questions is, why do patients with POTS have a high heart rate, and especially on standing? And I think most of us that spend a lot of time thinking about POTS acknowledge that the main problem is that there's not enough blood getting back to the heart. It's something that Professor David Systrom at Harvard has termed cardiac preload failure. And so the problem is that ultimately the heart can only pump the blood that it sees, as you can see on the next slide that we'll put up, right? So ultimately, you know, if blood's not getting to the heart, the blood won't leave the heart, and that poses problems, because when you need blood to the muscles, it's not there, and then the only way the heart, you can increase the amount of blood supply is really to increase the heart rate, which has its own problems, as you know. Now, we know most patients, when they feel really unwell upright, lying down with a fixed pulse really quickly improve a lot of the symptoms. And one of the key reasons is that you've eliminated the gravitational pull of blood away from the chest to below the chest. And the blood comes back when you lie down. That can improve the blood flow. And this is a strategy that you can't spend your life lying down. Part of the strategies we use to try and increase the blood supply focus on this. And today, there are some interesting experiments planned, not necessarily for things you want to do to make yourself better, but to show the effect of increasing and decreasing preload on the blood supply that we can now track and measure at home using this novel Lumia device.
Awesome. So to actually kind of bring that to action and then bring that to life and actually visualize this concept of preload that Dr. Raj covered, Greg has also actually built a little demo for us all. So this is Bobby. You want to go ahead and add to the screen. So Bobby is our most compliant volunteer ever, who has gone through open heart surgery and has brought the heart out. So that's the blue a balloon that you see there that the thumb is going to be pressing. So go ahead and play the video. Well, you'll see what this video is. You can see the heart fills, and this is beating at 60 beats per minute, about once per second. It's normal heart rate. You see how the heart is not filling all the way, so the balloon is still kind of wrinkly. And that's because it's not getting enough preload. But now we're going to put the legs up, so the gravity is going to push the blood in the legs to fill the heart better. And now you can see that the heart is actually being filled fully before it squeezes each time. So that's why it's able to squeeze a whole lot more blood, because your heart can only squeeze out the blood that it gets to, as Dr. Raj covered. And so as you see right back, when we put the legs back down, the heart cannot get filled enough again. And that is the basic principle that we'll be covering today in today's Lumia Lab Live. So all that to say, we'll actually be, let me bring over the protocol here. So today's community protocol that we'll be doing, as you can see on the screen here, is as presented. But Dr. Miller, would you take it away?
Yeah, so I'll explain today's protocol. We are going to have people live during the session or afterwards do this quick protocol where you'll lie down, then put your legs up, then stand, and then lie down again. So science always starts with a question or a hypothesis. And today what we're going to test is whether blood flow does improve with putting the legs up in people with orthostatic intolerance. We want to see what percentage of people this is effective in, and how much can we increase preload just by putting legs up. So I'll explain the 4 steps of the protocol. Like you see below, we're going to hold each one for 3 minutes. However, if you feel lightheaded or any symptoms while standing, you can cut that short. So if you want to do the experiment here or afterwards, all you have to do is start a live mode with your Lumia. You have to have a Lumia to participate in this experiment. So you can collect the data now or do it in your own time. You're going to then capture a screenshot of your data afterwards and either send it to the Reddit link, and you can do this anonymously if you create an anonymous account on Reddit, or you can also share it in the private Lumia Facebook group. So we're going to have a little chat while people can experience this protocol at home. Are you ready to collect some data?
Let's do it. So I'll just add a couple more thoughts to that. So for this one, we do recommend, if you see in the YouTube, the video description, there's a link to a Reddit post that we just made earlier today. So that's where we'll actually be sharing in the comment thread if you're comfortable sharing in. It is a public forum, but the idea there is we're going to make it public available because not everyone is a Lumia member now and can access Lumia just given the current state of the product. And so we want to be able to share those insights that we're going to do with more people, so we can benefit more people, we can help educate more people with the power of the community. So that's the idea behind the Reddit, if you're comfortable sharing. But we'll actually go and get right into it today. So I'm actually sharing my screen. I have my phone. That'll be an interesting thing. We'll actually take questions a little bit later, but you can, for the purpose of this, you may have a different result, so it'll be kind of interesting to see. And maybe comment that into the Reddit thread if you are connected to Fluids. But that said, I actually have Maggie from manufacturing. We're pulling the whole engineering team here. So this is Maggie. She'll actually be our guest for today in helping demo what's going on in the protocol. So I'll actually scoot over here. I'll keep this going so y'all can see the protocol. Now, if you don't mind sharing my screen, I will show you guys just how this works here. So can you add my device to the stage? It is under Lumia, Daniel, am I sharing? Yeah, laptop. There we go. All right. Okay, so I'll still try to be here. All right. So if y'all, y'all can get find a place that you can lay down flat, but you want to find a place also that you can put your legs up. So ideally, it is like a sofa near a wall. It could be on the floor, and you're putting your legs up from on the wall as well. But you want a nice flat surface. So Maggie, will you please go ahead and lay down? So Maggie already has. We're wearing the clip right now, but and Maggie is as well. But we will. What you want to put your Lumia in? You want to take it out, and you can see. Actually, I'm sharing my screen here. We're going to be doing a live mode to capture this data. So you want to first make sure that you're fully synced up. So you can check that to make sure that when you click into the device status page, it should show that it's fully synced and up to date, which I am on a build that is a little bit slower. You can see that synced to just now. So you want to make sure that you're synced up because that's a prerequisite to start live mode. Now, for those that aren't aware, Lumia tracks measurements right now about every 4 minutes, and then but what live mode does is it tracks every second, but you have to trigger a live mode inside of the app. So to do that, go into the app, and then once you're synced up, you can hit the plus sign at the bottom, and then you want to hit live mode. And when you do a live mode, what we're going to be doing actually is we're going to go for a 20-minute live mode. So there we go. Because our protocol is about 12 minutes. You want to hit 20 minutes, we can end it early when we're done. So I'm going to go ahead and get started now, where we're going to go ahead and start the live mode. This sync it usually takes 10 to 20 seconds to get live mode started. I'm also, so one thing that is a little bit different that you'll notice, and that's going to be coming out to the community soon, is I am on a build that should be syncing a little bit faster. Once once it gets started, it should be a continuous stream. But so what you can watch here is, because we're going to do it every minute, I would zoom in. We're going to let it go ahead and start syncing. And once it starts syncing, all right, there we go. Maybe I did not download the faster build, but here it is. All right, so here we go. So the previous build, which this might be on, it takes about 15 seconds to sync. So we're a little bit, we're just catching up. But here we are at about like 75. So everyone at home, y'all can go ahead and get started, where you just lay down, and we're gonna start the timer of the first 3 minutes together. So I'll give everyone another minute or so before we'll start the official 1 minute session. And then we'll actually target doing that. The orange line says what is current time. So when this orange line reaches 7:42 p.m., that is our first start of the 3 minutes. So we'll start at 7:42, and then we'll be putting our legs up at 7:45. And then at another 3 minutes, we'll be standing up at 7:48. And then we'll be laying back down at 7:51. So the protocol will officially start in about 10 seconds. And then we'll just hang out for a few minutes.
Yeah. And if you're not ready to start it right now, you can follow on your own time during this as well and just finish a little later. So in the meantime, Dr. Raj and I are going to just...
Real quick, we're starting now. So official 3 minute has started. So let's do it. But again, you can, as Amanda said, follow along on your own time. This Reddit post will be open for a while, so you can always share that screenshot when you're ready.
Mm-hmm. Yeah, we're leaving it open for a week. Is that correct?
Actually, for this first one, we may do some write a little mini post on it in about 1 or 2 weeks. But you can share your plots and also view the plots of others at any time. So even if you see this 3 weeks later, feel free to contribute and look at how the other community members are doing.
Okay. So Dr. Raj, I have a few questions for you about this topic. So you gave us a great explanation about what preload is and how raising the legs can improve preload. But why does preload matter for POTS, orthostatic intolerance, and related conditions?
So what I was trying to get at is that ultimately, the heart needs to deliver a certain amount of blood to the body to do its things. And when you're exerting yourself, you're using your muscles, you need more than when you're not doing stuff. And we measure that with something called cardiac output, which is a measure of how much blood is delivered per minute, right? So cardiac output is made up of two things. One is the amount of blood that the heart delivers with every beat, called stroke volume, and the heart rate, the number of beats you have in a minute, right? So it's actually fairly simple math. And it's stroke volume that's really the key that's affected by preload. If you aren't delivering as much blood to the heart can't move it forward, right? The heart, can only, as Wouter said, the heart can only, push out what comes in, what it gets. And so the goal here with increasing preload is actually to try to see if we can get the heart to increase its stroke volume, the amount of blood that comes out every time. It's not exactly the same as efficiency, but in some ways I think of it as making your heart more efficient, right? Where it just does more with every beat. And then the hope is you don't have to raise your heart rate as much to get the blood that your body needs in a minute. And you have less tachycardia and hopefully less symptoms with that. The other part of this is that, I'm a cardiologist and I'm focused on the heart, but it turns out my neurology colleagues keep telling me the brain is more important. And one of the things that we know is that when the heart's not delivering as much blood, that can actually compromise the blood flow in the brain. And the hope is that these maneuvers, by making the heart more efficient, will actually improve.
Sorry to interrupt, Dr. Raj. We have 10 seconds before the transition to legs up. So Maggie, if you will, in about 10 seconds, let's go 9, 8, 7, 6, 5, 4. All right, Maggie's going for it already. Go for it. Okay, so 7:45, we're going legs up. We found an interesting chair situation here, but I think it's stable. But hopefully you all have a more stable wall at home to do this with. Sorry, Dr. Raj, you can continue.
No, so I just making the point that the brain blood flow is affected, and that's actually an area that has become it's been around for a while, but I think there's a lot more interest in trying to understand issues around brain blood flow and potentially reduced or compromised brain blood flow in patients with POTS and related disorders.
No, I appreciate you saying that. As a neuroscientist, I do believe that the brain is important for flow. I mean, without the heart, we can't pump blood flow up to the brain, especially against gravity. But yeah, that's definitely why I think that's related to why patients experience things like brain fog, lightheadedness. It's because of the brain. I mean, palpitations are another symptom that's more related to the heart. But anyway, I'm wondering what data is there to show why preload is lower in POTS? Why can't patients get the blood flow up to their heart?
So, this is actually a good question, and I'd say one that's not fully answered. But when I went down to Vanderbilt, 20 years ago, over 20 years ago, my first project dealing with POTS actually was trying to figure out whether POTS patients had leakier vessels. So when they stood up, whether we all can lose a little bit of fluid, because of the pressure of gravity, and whether this was worse or exaggerated in patients with POTS. So we weren't able to show that. But one of the things that we did find was that fairly consistently, on average, and there's a spectrum among different patients, but on average, POTS patients tend to have a lower blood volume than one might expect. And blood volume is a bit of a difficult thing to assess, mainly because it varies with size, and it varies with sex, and it varies with body composition, right? But it's not a hard concept that Andre the Giant, for those that you remember him, would be expected to have more blood than Amanda, right? Just because he's so much bigger. But if you can account for that, we found that POTS patients had a deficit, about a 10 to 12% deficit on average. And we actually studied healthy control subjects as well, healthy controls, and on average, their blood volume was what we expected from the math, from the formulas. So the formulas looked to be okay. It was the problem with the POTS patients. And we think that, there may be different explanations for that, but one of them is there may be problems with the hormones in the kidney, for example, regulating the blood volume. There's a lot of interest nowadays in disorders like May-Turner syndrome and other related vascular compression disorders. And one of the ways that they can cause symptoms is that if you start obstructing some veins, it's a little like Jurassic Park. Nature finds a way. The blood will find a way to get back. And it does that by creating or enlarging tiny veins to bigger veins. And so you can get a whole bunch of veins in the lower part of the abdomen and the pelvis. And so when you stand up, all of a sudden, there are all these veins for blood to go sit in. And that blood's not coming back to the heart efficiently. The veins aren't able to, it's harder to squish it back because of the gravity effect and more vessels. So there are a bunch of things going on that contribute to that in POTS. Some blood volume related and some gravity related.
So I apologize. I had a little bit of a technical difficulty here, but we are actually going to be transitioning to a standing. I missed the 3-minute window, so we're going for the 4-minute window. So I suddenly made legs up go for 4 minutes, but at 7:49. So as you can see here, in about 15 seconds, we're going to be going ahead and transitioning to a standing position. So let's go in 10 or 5, 4, 3, 2, 1. Go ahead, Maggie. All right.
Let's see what happens to Maggie. Maggie does not have orthostatic intolerance, as far as I know, but we're still seeing some change.
We'll find out.
Yeah. Is this a test? Maybe. Okay, so that's a really good description on what can go wrong in POTS and people with orthostatic intolerance. Now, putting your legs up the wall while we're using it for this experiment is not super practical in people's lives, I guess, depending where you are, if you're at home or in public. So what are some practical ways that people can try to increase their preload?
So, we try to target the two problems that we've talked about. So the blood volume is low, and we want to try and increase the volume. And that's where I suspect almost everyone watching today has been told to try and increase the amount of salt they take in their diet and to drink lots of water. And these really are part of a fluid retention strategy designed to try to increase your blood volume. That's why we do it. There are drugs used on top of that, but non-pharmacologically, really, this is a foundational treatment. And, it's important that it be done aggressively. The other part of it is that, most patients, as we said, get their symptoms when they're upright and better lying down. And that's because fluid shifts downward because of gravity away from the chest. And so we've done a lot of work here in Calgary, led by Kate Bourne when she was doing her PhD in our lab, looking at lower body compression. And we're big fans of using compression garments, compression tights, from the abdomen all the way down to the legs. The most important area is the abdomen and pelvis. You don't want to wear just knee-high socks for this purpose, but the compression it doesn't eliminate this fluid shift, but it decreases it, allowing more blood to keep coming back to the heart realistically, and helping lower the heart rate on standing.
It's something I discuss with people with POTS all the time, that I think it's oversimplified that blood pools in the legs, and people don't appreciate that there's huge veins in the gut region where blood also pools, especially, well, maybe there's not a lot of data to support this, but after meals, postprandial, that is a common time for more blood to pool than in the gut. Daniel, are you about to interrupt us?
I am about to, you still have another 20 seconds.
Okay.
So,
I won't jump into another question right now.
Well, I actually might just really quickly comment here. So what we can see here is during the laying period, actually first, sorry everyone at home, I'll count you down because we're going to go ahead and lay back down. And let's stay focused on the next action, and then I'll explain what's happening. So we'll give it in about 10 seconds. We're going to go ahead and lay back down. My ability to count, I'll say in 5, 4, 3, 2, 1. Can you go ahead and lay back down? Sorry, my 10s get distorted. 10 seconds turns into 3, so I'm not predicting that very well. So, all right, so we're gonna go ahead and lay back down for another 3 minutes, and then I'll start to talk about what we're starting to observe here while we wait for this next session, or the next period. So, as you can see, Maggie, when she was laying down, we can see this in this period, she was laying down, and she actually is not that fluid responsive from the sense that when her legs were lifted up, she had a small increase, but not a significant increase. Some people may have a much larger increase in flow with more blood filling the heart. Because if your heart, as you saw in the demo, if it's already getting almost filled, then pushing in a little bit more is not going to push it up that much more. But if your heart is very underfilled, if the preload is very low, putting your legs up can fill the heart a lot more in that period of time and increase your flow a lot. So this is kind of an idea of like how much can your body, if you put more blood into your heart, is it going to increase your flow a lot more? So Maggie was not that responsive.
Daniel, before you get on to the next point, I want to follow up on that. We've had one question right at the beginning about, can I do this with my IV fluids? And I think it would actually be really interesting for that person to do it, maybe not today, but do it before their IV fluids, and then maybe after their IV fluids, and see, because I suspect you may see something along the lines of what you're getting at, which is the response I think will still occur, but the magnitude or the amplitude of the response may be different.
Yeah, the idea is you're more hydrated, you have more blood in your blood vessels, then the leg changes. You're putting your legs up is not going to change how much your preload as much. But if you're very dehydrated, then your heart is really starting off more wrinkly, and so putting your legs up is really going to increase the amount that your blood flow is able to increase. So that's a very interesting concept. Let me continue speaking to what we see after. So after we saw a pretty steep drop, and this is actually quite common for anybody. If you've been laying down, especially if you put your legs up for a while, when you get up, you're going to have a kind of steeper drop, but it's the recovery from the drop that kind of matters. So as you see here, usually you need to actually see for like 10 minutes in order to really see like where you start to see someone that's really orthostatic intolerant look different than someone that's not. But you can see Maggie was slowly starting to climb up as her autonomic system was squeezing the blood vessels in her legs, because the blood went down to her legs and it was starting to squeeze it back up. So we were recovering slowly, but we laid back down before we could really let it fully recover. Now, that's kind of what we were seeing. And when she lays back down, though, all of a sudden, all that fluid that gravity was pushing into her legs when she was standing up is rushing back into the heart. So we see this significant effect because gravity is extremely strong on a column of fluid, which is basically a human body. So that's kind of why we're seeing such a dramatic effect. And these are all related to preload. It's all about how much gravity is acting on your blood in your body to push it towards your heart.
Yeah,
anyways,
really cool. Can I just make a comment? It's really cool to see Maggie's data live, and I'm wondering how it's going to affect the various people in our community, since POTS is not homogeneous. It's not all the same. So I'm wondering to see in our patients or people here with hyperadrenergic POTS, maybe you have a different orthostatic syndrome or long COVID, ME/CFS, whether we still have these preload issues.
Just Daniel, I suspect most of your audience is more familiar with
sorry, Dr. Raj, I'm going to interrupt you. I keep interrupting you, my bad, but we're going to go ahead and stop here. So we're over here. So you can hit stop live mode. It's going to take a little bit. So you want to just hang out for a second. And then what we're going to do before you share your charts into on the Reddit channel, if you could please add tags to them. Do we need to add tags? Let's.
You can see their position too, right?
Yeah. We might skip the tags. Go ahead and share. I want to create less work for you. If you want to add the tags to say laying down, legs up, standing, laying down, or lying down, then you can, and you can share that in. Otherwise, it is the same fixed protocol. So feel free to just share the chart as well, because we should probably still see the same types of effects. So go ahead and take a screenshot of that at your appropriate time whenever you're able to finish the experiment, and then we can just see how people are doing. So, and Dr. Raj, you can continue.
Well, I was just going to say, your audience is probably more familiar with the device than I am. No, don't do that. Bring it back. Bring it back.
Oh, all right. Okay, never mind. I will not add an event.
I assume the white is the flow indicator and the blue is the heart rate. Is that right?
Correct.
And so again, we've been talking about the flow, but if you look at the blue, right, when the flow dropped, the heart rate went up. When the flow went up, the heart rate dropped, right? So this is what I was trying to explain earlier, that the heart rate is really the body is trying to deliver a certain amount of blood, and over time. And if it can't do it by flow, it does it by heart rate. But if it can do it by increasing the flow, the stroke volume, the amount of blood coming out, then the heart rate doesn't have to go up as much. So it's just a nice demonstration on the screen. I just wanted to point that out.
Awesome. Yeah, so we are actually starting to run short on time here, so we have a couple of minutes left. Are there any questions from the group here? All right. I think we're okay on questions. So let's actually talk about, so please go ahead and share in the Reddit or the Facebook, but we will have another Lumia Lab live next month, and this one will be on compression. So make sure to bring your best compression, because we're going to start seeing different styles of compression, exactly what garment and tightness is, and we'll be coordinating a little experiment there. So that's what you can look forward to. We'll give some more information announcements later. Yeah, thanks for bearing with us. We had some audio-visual difficulties for our very first one. This will get smoother in the next ones. But yeah, actually, we have 2 more minutes left. So any other comments, Dr. Miller, Dr. Raj?
Oh, so our next Lumia Lab Live will actually be live from the Dysautonomia International Conference. So if you want to come see us in person and do it with a group of people, you actually can do it in person as well as virtually.
Yep.
And of course, a special thank you to Maggie for offering her data. Without her participation, we'd have a lot less to look at.
Yeah. Awesome. Well, we'll go ahead and end. Thank you, everybody. Thank you for joining our very first Lumia Lab Live, and we'll see you next time.
Bye.
Bye-bye.